All right. So it's Sunday. I woke up today at 4 a.m., so I don't have much energy to do this stuff, but let's just try to quickly solve some problem under 40 minutes and see how it goes. The stream is for entertainment purposes only. Let's jump right in and see what we've got today. All right. Pick one. Nice. Medium problem. Battleships in a board. Given matrix Mn board where each cell is the battleship or empty X or dot. Return the number of battleships on a board. Of the shape 1 of K, one row, K columns, so K1, K rows, one column. But K can be of any size. At least one horizontal vertical cell separates between two battleships. I either know adjacent battleships. All right. So it sounds like simple DFS problem. I'm not even sure what to look for. So the complexity will be quadratic with respect to the length of the array or linear with respect to the number of cells. So not very complicated. So let's just go straight ahead and solve it. I mean, that's a good point. We all know it's different. I mean, there might be some other options like go and investigate any line independently. All right. Int DFS. It's not actually even depth first search. It's more like just so the idea is you go through every cell. Once you hit the X, you start going either left, right, or whatever, right? And you go there in all directions, right, to cancel out all of these X and put them as dots. Once you've done so, you know this is one ship and you can continue. So let's do this. For int I equals 0, I less than board size, I plus should be super straightforward here. The same thing is J. Now it's only, I think it's I, then it's J. Although I guess board is, it's M times N, so it's not necessarily quadratic. All right, so what do we do? All right, so all we do is this. It's super straightforward. If board ij is what is the chart, right? Is X, right? That we say CNT plus plus. Then we do DFS. ij board, right? And once we do this, we return. Once finished with this, we return. Oh, I think I don't have enough brackets here. Return CNT. DFS. J and so we know that the current ij is x, right? So we say board ij equals dot. Now we can reduce number, of course, here. Or actually even better, right? So we say if I greater than 0 and I less than board size, right? And then this it should be and. So greater or equal to 0, it can be 0, it's fine. We don't want negative. And I shouldn't return anything actually here. We don't need to return anything. And same here for j, right? J less than the board I, because we already checked I, so we can use I now. And finally, so if we are within the boundaries, and again, board ij equals x, then we do this, and we do as well DFS I minus 1 j board I plus 1, then we fix I, and then we go with j minus 1 and j plus 1. Looks straightforward. That's it. So how much time I've spent already, I wonder. All right, 9 minutes. 9 minutes, so maybe it passes or not. I'm not going to use examples to debug this code. All right. Something violates the boundaries. If I is greater than j, I less than board size, j greater than 0 equal to j less than board I size, and board ij equal x, we make a dot, and And that's it. So these definitely can. Ah, yeah, they can. All right, let me try one more time. Seems it works. All right, we passed it in 10 minutes. And even debugged it. Everything is in 10 minutes. Not bad for medium problem. So the time is good. Memory is not great, although we only used, in terms of memory, 1 int here. So let's go back to description. So can we save some here? Or 1 extra memory and without modifying the values board. We can't modify the values board. Interesting. But okay, follow up. I'm too lazy. So what's the size here? 1 to 200. All right, so I'm not quite sure if 256 is sufficient. So, but 16T definitely should be sufficient. Oh, sorry. Yes, it's like this, right? Or vice versa. In 16T. So yeah, let's just run a couple of more times and see what's the best course we can get. Again, we do this 01 extra memory, no problem, but we do modify values board. This is basically to check that we already checked those. It's basically like in the game, right? When you ask, so this cell, okay, is it either shipped there or not? So that's what this thing does. The problem here is that they don't want us to modify it, so they don't want this right line. Without this line, and having O1 memory. I think you can. I think you can just run the counter from 0 and then use while cycles either until you have something to the left or to the right, and then do shifts. But yeah, this one clean and understandable. So let's stick with this one. Just submit a few more times to see what's scores we can get. Interesting. So the memory is still the same. Can I get to 8? I guess no. It will fail because there may be more than. Alright, it can be 3, 3, 1. Yeah. So 16. Just 2 bytes of memory, and in terms of memory, we're bad. Alright, with just 8 megabytes per millisecond is best of the best, so I stick with these numbers for today. Why do we finish that fast? So let's switch to the whiteboard. So we have 99 for time, and 79 for memory. $99 times 79 memory. Total is 178. Given the fact that this is the medium problem that we solved it in 10 minutes, I mean, it's kind of an easy problem. Let's just do something new here, right? Alright, I don't have too much of ideas, so because we solved it, let's just stick with smiley face. Alright, so that's it for today, but before I stop the stream, let's just return back to the main screen and just go through the discussion of what was the constant memory DFS. AIJ, right? It's not constant time, all right? Why it's 201? It's constant in the sense that no, it's a high. It's a high because you know the maximum size of the matrix. Technically, no, it's not the constant time solution, so it's not the follow-up question. Yeah, so I would imagine just go through cycle. If it's X, then you can't find ship earlier, obviously, right? But that makes sense. Yeah, you don't need DFS. You just check if the prior cell, either on the column or on the row, is X. Exactly. Yeah. Simple algorithms requires simple but genius, right? You just why bother with depth first search if you know that you start with lowest possible row to the from row 0 to row whatever and same with column, right? So all you need to check either preceding on top or at the back is already X. If so, then it's not a new ship. You just keep it. I wonder why it's not an easy problem then. I mean, it's not an easy, obviously, because you're kind of using DFS here, right? But again, given the context, really, you don't need to use DFS, and this is just a straightforward counter, basically, a little bit weird, but still, and it's not an easy, it's medium problem. And look, a lot of people don't like it. Is it for a reason that it's too easy? I don't know. Right, so with that, let me finish for today, and